Hey, so I just wanted to show this prototype I've been working on for Quake engine, or well, not really Quake engine, Quake map viewer basically. So there's no actual real gameplay yet, it just draws a wireframe, but yeah, I think it's pretty nice. You move around and stuff, see everything, pop in and out. It's pretty cool because it uses the PVS, potentially visible set, which getting that working was kind of a pain. I'm gonna show some resources I used that made this possible, because there's a lot less information about Quake. I guess there's less exhaustive information about Quake than there is Doom. I'd say there's more than with Duke Nukem 3D, which was another video I made about a Duke Nukem 3D type engine. But yeah, getting this all to work was took quite a while. But yeah, I'm really proud of what it is. The line drawing, popping in and out, that's just my line, the way I do line drawing. I just do, just to make it so you can kind of see what's going on without having to do all the line clipping and all that stuff. So the lines pop in and out instead of actually clipping to the view frustum. And I don't actually do clipping based on where you're looking. I just use the PVS. For newer computers, these kind of maps, you can just render the whole thing and it runs totally fine. But, I like the idea of, having an engine or a game that can run on some crappy hardware. Because, yeah, good hardware is not always available to everyone. It's gotta be nice to find a game that works on really crummy hardware. Not saying that this is as performant, like I said. I'm skipping a whole, or actually two optimizations that are done in Quake. I'm just using PVS, which is a major part of it. But then there's also clipping against the view frustum, and also converting screen information like what you would see here, all the edges, and basically converting all the surfaces into individual scan lines or spans across the screen, so that way there would be zero overdraw. But yeah, mine's not even close to as performant, but hopefully just I wanted to get the PVS in because that's like a really big part of the optimizations. You clip out whole parts of the map, based on what you can or can't see. And this idea of like just removing stuff that you can't see, it's not really that novel. It's more so, I think, automating a process to get the information you need to be able to do that quickly at runtime automatically. So you make a map and then it just goes through and gives you all the information you need to know. I'm standing here. That went into a wall. What other things can I see? Generating the PVS was the most time-consuming part, or maybe not the most time-consuming. I think it was, and it could take on like a workstation like 10 minutes on a machine that's more powerful than what people would be playing it on. It was a very difficult problem to solve, at least for like levels that they wanted to make with a level of detail, because for the time, Quake's levels are very, very detailed, and having them perform well without level designers needing to manually generate some kind of PVS. But yeah, so this can take, the level I have here is rgcastle.bsp. It is a pretty cool puzzle level I played using Liberate Quake, which is basically replaces all the proprietary parts of Quake with free versions, so you can actually play maps made for Quake without actually having Quake, which is nice. I used Dark Places with Liberate Quake, and I was able to actually play this map. It's a little puzzle map. It's pretty cool. I think it's on Quadiction. I think this website. I'll have a lot of links in the description to all the resources and stuff, and also to this map. Let's look at the source code. So I want to go through the difficulties I had. So you'll see here This was the main source that I got from. As you see, this is for BSP for Code Source, which is a predecessor to the source engine used in Half-Life 2. The format they use is actually almost exactly the same. The only real difference is the texture information. So there's isn't texture warping on the slopes. And since my engine doesn't have any textures right now, I haven't had to discern between the file types. Like when you run it, like ./a.out, you actually put in the level you want to load. But I just have it so that it so just we'll see like if you provided a value. If not, I'll be like, oh, there's no value provided. Just, make sure people know. and I know. And if not, it tries to load the first level of Doom, which is called E1M1. I mean, I think the first level of Doom is called E1M1 as well. But of Quake, first level of Quake. And then after that, if that doesn't work, then it just tries to load the map I've been using that I have. I just use these values here for max that are provided here, and I just put them in here. It's like, yep, maximum size for everything, and I just allocate it all right away. Just boom, that's it. I would load everything in to a pointer that I would allocate right here, and then I would free it right after, because it would just be used to just load in just all the data, and then I would loop through and actually put everything in the structures when I needed to. So yes, I was dynamically allocating and then deallocating, and that was actually a problem. It wasn't the way I was allocating stuff or reallocating. I used realloc. It was with stupid temporary buffer. So I was just confused. So I was just, okay, I'm just going to get rid of all that. Just have like a maximum number and just allocate all of it right away and just fill it out. And then as I was going through this, I got to here and I made such a dumb mistake. I tried to be cool and just put like 9 to like 13 here. And so that's completely out of bounds for that. And I came across that at the very end of doing all this rework, but I think it's for the best. And I guarantee you that was the problem the whole time. Also, you scroll down here and you're like, using this as my primary resource, and then scroll down here, it's like, oh, models. I pretty much dismissed this right away. I was like, oh, models, that's just enemies and stuff, and I don't care about that. And the information here is not super thorough. Like the next to this value is just question marks, but we have this beautiful, beautiful website, which this is actually based on an old version of the map, so it's not the same, which is why initially I dismissed this source. But it does. I don't know why I opened a new tab. It does have information on the models, and you'll see here, the first model is a whole level itself. And I was having a problem where, because I just treated all the leaves as if they were part of one tree, but they're not. So and the effect that was having was when I would go through all the leaves and look through all the, see like, oh, what's visible from where, I would be indexing into leaves that were part of different models. So there would be these other models that would pop in and out, like pretty much randomly, not actually random, based on, memory locations and all that. And it was annoying because, I wouldn't be indexing outside of it. But yeah, it was just the entry point at which I was going around. So down here, you'll see, also this run length encoding is kind of annoying. But, this is a simple example on this website that, basically has this. And I did, this is kind of cursed. Used to this, L equal 1, L is less than the, and then you get here and you increment a completely different value. It's like, oh man. And then down here, this is pretty slick way to iterate through all the bits. It's pretty nice. And then comma L++. Yeah, honestly, is it at the end? I think it's at the end that this happens. But I didn't even know that was a thing. I didn't, but now I do, so that's cool. So initially, I was having the root node I would start, traversing the BSP tree from was just 0, because it's like, okay, 0. That's the origin, And, I got those results of it pretty much working. But when I put in the PVS, tried to, use that information, then it was all weird, different models popping in and out. So that's because I wasn't entering from the right root node. I don't know where I was entering from, but whatever 0 was. But what you're supposed to do it is the first model, and it has nodes, and so the first node in that is the root of the BSP tree for the level. And so once I did that, and also corrected some stuff I messed up in the rework of the map loading, and it freaking works. Oh, it was so satisfying. Of course, all the models aren't there. Like, there's supposed to be horses in there, and there's supposed to be like a cracked wall that you put dynamite in there. Like I said, this is a really nice map. The puzzles aren't like super complex. It's, get through in less than half an hour. But yeah, it's really nice. I would definitely recommend it. Oh yeah, and another thing that's you get from this models is the number of leaves. So that goes right here. So I'm not indexing into leaves of completely different trees. So yeah, that's always good thing to do. And the actual rendering part, yeah, it's kind of cursed. I have to mess with like the bounding boxes were giving me trouble, because my X and my Y and Z are flipped, but also the Y is inverted. And for a bounding box, inverting it means the minimum is now the maximum and maximum is now the minimum. But I didn't realize that at first. So yeah, you have to switch. You have to invert and switch these with each other. So that's all nice and proper. But yeah, my rendering is actually up here in the render node function. That's load BSP, render node. As you see, I have this variable here, order. And I was using that to visualize. I would divide this, the color values by O. The brightest is drawn first, darkest drawn last. So it's just a good way to visualize it, and it helps figure out what's going wrong. Very useful. But yeah, and also some stuff with, like if it's a leaf, the index actually needs to be inverted to get index into the leaves lump. And then also, you gotta, if it's a leaf, you gotta look at marked surfaces and then use that to index into marked surfaces to get the index to face. So yeah, but mostly the same. And then my projection is just very simple. You just, get the position of the point relative to the player, and then you rotate that point based on the horizontal looking, and then you rotate that point based on the vertical looking. If any of them are behind, then it just, any points behind it just doesn't draw anything. And the same if it's too far outside the screen, just to keep performance working well without having to deal with all that clipping stuff. But yeah, and then the projection is just pretty simple. It's just x, y times this value, which is just some value. It's a magic number. But I'll probably pre-calculate this so I can actually set a proper FOV and have it be consistent regardless of what render size I have. So yeah, very simple, no matrix multiplication or any of that jazz, just very simple plotting points onto from 3D to 2D screen from a certain perspective. But yeah, so that's my little program I made over the course of a few weeks. I definitely would recommend, if you didn't if you didn't understand anything I was talking about, you probably would have just not watched this far, but still here and you still aren't understanding anything of what I said really, then I would highly suggest Matthew's Ramblings YouTube channel. Talks about Quake and how the rendering works, collision works, PVS works, all that jazz. It's very nice. Also these websites Very nice. But yeah, that's it, I guess.